Hello, my name is Peter. I work at Avast, Thread Labs, and I will tell you a few words about our decompiler that we are going to open source in December. So the compiler itself was developed by AVG, and we were not really trying to open source it because some of the critical modules were proprietary. But then when Avast bought AVG, they were like, hey, this is really cool. Can you do something about it? Can you put it out for the public? We were sure, but we will need some time to rewrite these modules. So we did, and now in like a month, it will be public under the MIT license. So the compiler itself is based on LLVM project, and it is using LLVM IR as intermediate representation. Its structure is similar to typical compilers, like 3 parts. It takes binary and it produces some high-level language. In our case, it's C. I will go very fast over the structure so you have idea what we do and what you can do if you try it. So on the input, we've got binaries. We support all the major formats. And then we've got some libraries that can uniformly represent them. So we parse it, and then all the other code just works with the library, and it doesn't matter what is underneath. We also have an image loader library, which is trying to simulate statically what would operating system do, and how it would be loaded into the memory. There are some other stuff like unpackers and some signature detections in the ARA and so on. The core is working on the LLVM. This is the structure of it. If you were using a CLang compiler, it will be somewhere here. CLang would take C and produce LLVM, and then it would be optimized and output, and we go the other way. So we just take an empty LLVM module and we try to fill it by decoding binary and then running a lot of passes and get something like C. The decoder itself was the critical part that was originally, it had a bad license, but we rerouted it using Capstone disassembler. So now we've got a library that is using Capstone, and you give this library binary data, and it will give you LLVM IR. So we can use it with some kind of implementation recursive disassembler and get the LLVM IR, then we can optimize. The last part will take the optimized LLVM IR and tries to lift it up. LLVM IR is kind of a 3 address code or maybe some fancier assembly. And we translate it to some higher representation which can represent control flows like if then else, whiles, force, switches, and stuff like that. So then some more optimizations and then the C. All those little boxes in the pictures were like libraries. So our decompiler isn't like a monolithic tool like IDA, yeah? But it is just a collection of libraries that we link together by some scripts. When we will open source it, all these libraries will be in separate GitHub repositories, and you don't have to use the entire decompiler. Maybe you will just be interested in the loader or for example, just the Capstone 2 LLVM library. So all those libraries are somehow standalone and can be used separately. Like I said, we will open source it in about a month under an MIT license, and we will have a full presentation about this topic in BotConf in France in December this year. So thank you very much. That's all.